when all of a sudden you see your friend struggling out in the water. You want to go help him as quickly as possible, so which path should you take to get there? The shortest path is a straight line, so you could head directly towards him, but you can run faster than you can swim, and this path requires more swimming. So alternatively, you could run down the beach to minimize the distance through the water. But now the total distance is longer than it needs to be. So the optimal path, it turns out, is somewhere in between. To be precise, it depends on the speeds at which you can run and swim. Now, you might recognize this mathematical relationship because it is the exact same law that governs light passing from one medium into another. So light also takes the fastest path from point A to point B. What's weird about this is that as humans, we can see where we want to go and then figure out the fastest route. But light? I mean, how does light know how to travel to minimize its journey time? Now, here is where my misconception comes in. I shine a laser beam. The light just goes in one direction. I throw a ball. The ball just goes in one direction. I would have answered, there is nothing strange about this. Light sets off from point A in some direction, and then a little while later, it encounters a new medium. And due to local interactions with that medium, it changes direction, ending up at point B. If you later find that of all the possible paths, light took the shortest time to get from A to B, I wouldn't think it was optimizing for anything. I would just think that's what happens when light obeys local rules. But now I will prove to you that light doesn't set out in only one direction. Instead, it really does explore all possible paths. And the same is true for electrons and protons, all quantum particles. So the fact that we see things on single, well-defined trajectories is, in a way, the most convincing illusion nature has ever devised. And the way it works all comes down to a quantity known as the action. In a previous video, we showed how an obscure scientist, Maupertuis, made an ad hoc proposal that there should be a quantity called action, which he defined as mass times velocity times distance. And he claimed that everything always follows the path that minimizes the action. Hamilton later showed that this action is equivalent to the integral over time of kinetic energy minus potential energy.
Hiểu bạn tất bật vì đam mê là vì gửi chút yên từ thiên nhiên để tái tạo tâm.
Action was useful and an alternative way of solving physics problems, especially when Newton's laws get too cumbersome. But then, around the turn of the 20th century, action showed up at the heart of a scientific revolution, the birth of quantum mechanics. It all started with electric lighting in Germany.
Think about what it's like in the 1890s, right? Electricity being more widely available, at least in urban centers, and things like, light bulbs. They were new. They were literally the hot new thing.
Germany wanted to replace all their gas streetlights with electric light bulbs. So an important question was, how do you maximize the visible light given off by a hot filament? Scientists at a German research institute, the PTR, studied how much light different materials emitted as a function of temperature. At low temperatures, each material gave off its own characteristic spectrum, mostly in the infrared. But above about 500 degrees Celsius, all materials started to glow in the same way, with an almost identical distribution of light. The hotter the object, the more energy was emitted at every wavelength, and the peak of the distribution shifted to the left.
But they still didn't understand how it worked theoretically. So that was sort of the next step, right? Because if you can understand how it works theoretically, then you can use that theory to potentially design new products.
They started by imagining the simplest object possible, one that would absorb all light that falls onto it and perfectly emit radiation based on its temperature. They came up with